Good day, everyone. Today, we are going to discuss quadratic inequalities. But before that, let us recall graphing quadratic inequalities on a number line. Suppose we have x is greater than 3. That means that we are looking for values of x that is greater than 3. Remember that we will use an open circle since our inequality symbol is greater than. Our graph will move to the right since it is also greater than. That means that our solution are 3 to positive infinity. But notice that 3 is not included, so we only use parentheses for 3. How about if we have here x is less than 3? Again, since it is less than, we are also going to use an open circle. Now we are looking for values of x that is less than 3. That means our graph will move to the left, which means that our solution set is from negative infinity to 3, where 3 is not included. Now, let us have x is greater than or equal to 3. Notice that this time we have here greater than or equal to. So that means we are going to have a solid circle on 3. Since it is greater than, then we are going to move to the right. And our solution set will be 3 to positive infinity, where 3 now is included. That is why we are going to use a bracket. Now, how about if we have here x is less than or equal to 3? Again, since it is less than or equal to, we are going to use a solid circle on 3. And since it is now less than, our graph will move to the left. Our solution set will be from negative infinity to 3, where 3 is included. That is why we have to use a bracket. Now, let us try this example. X is greater than or equal to negative 1. Notice that we have here greater than or equal to. That means we are going to use a solid circle on negative 1. And since it is greater than, then our graph will move to the right. For our solution set, it is from negative 1 to positive infinity. Notice that we use a bracket. That means negative 1 is included. For the next example, x is less than 2. Again, our inequality symbol is less than. So that means we are going to make use of an open circle on 2. Our graph will move to the left. For the solution set, we have negative infinity to 2. Again, it's a parenthesis since 2 is not included. Now, let us illustrate quadratic inequality. A quadratic inequality in one variable is an inequality that contains polynomial whose degree is 2. A quadratic inequality can be written in any of the following forms. It could be ax squared plus bx plus c is greater than 0. Ax squared plus bx plus c is greater than or equal to 0. Ax squared plus bx plus c is less than 0. Or ax squared plus bx plus z is less than or equal to 0. Let us have some examples of quadratic inequality. Number 1. 2x squared plus 6x plus 1 equals 0. Is this a quadratic inequality? The answer is no. This is not a quadratic inequality in one variable. The symbol used is an equal sign. This is an example of a quadratic equation. Number 2. X minus 5x plus 3 is greater than or equal to 0. Is this a quadratic inequality? The answer is no. This is not a quadratic inequality because the degree is not equal to 2. Number 3. The quantity x plus 2 times the quantity x plus 3 is less than 0. Is this a quadratic inequality? The answer is yes. This is an example of a quadratic inequality. When simplified or using the FOIL method, this is now equal to x squared plus 5x plus 6 is less than 0. This time, let us identify how to determine the solutions of quadratic inequalities. Remember, a quadratic inequality is a mathematical statement that relate a quadratic expression as either less than or greater than another. A solution to a quadratic inequality is a real number that will produce a true statement when substituted to the variable. Let us have an example. Are negative 3, negative 1, and 0 solutions to the inequality x squared minus x minus 6 is less than or equal to 0? To determine if these three are solutions, we need to substitute the given value for x and simplify. For example, when x is negative 3, we need to substitute negative 3 to all values of x. That means I will have negative 3 raised to 2 minus negative 3 minus 6 is less than or equal to 0. 9 plus 3 minus 6 is less than or equal to 0. 6 is less than or equal to 0, which is a false statement. Next, how about if x is negative 1? That means I will have negative 1 squared minus negative 1 minus 6 is less than or equal to 0. 1 plus 1 minus 6 is less than or equal to 0. Negative 4 is less than or equal to 0, which is a true statement. This time, x is equal to 0. 0 squared minus 0 minus 6 is less than or equal to 0. 0 minus 0 minus 6 is less than or equal to 0. Negative 6 is less than or equal to 0, which is a true statement. That means that negative 1 and 0 are solutions of the quadratic inequality, but negative 3 is not a solution.